Welcome to Ask and Learn.
Okay, so for this problem, we have a full M-ary tree, which has 81 leaves and a height of 4. So the first part of this, we're going to give the upper and lower bounds for M. And then part B, we're going to find out what M has to be if T is balanced. So we have a M-ary tree, height of 4, and we know that there are 81 leaves. Okay, so the very first thing we need to do is figure out how many internal values we have. So I'm going to use I equals L minus 1 over M minus 1. So we know the total number of vertices, or see if we can find that out. So we have 81 leaves minus 1 over M minus 1, which is going to be 80 over M minus 1. So M minus 1 can be 1, 2, 4, 5, 8, 10, 16, 20, 40, or 80. So those are all the things that can divide into 80 to give us an integer. So then that means M has to be 2, 0, which can't really happen, so 1's not a possibility. 2, 3, 5, 6, 9, 11, 17, 21, 41, or 81. So we want to go through and look at each one of these to figure out what is the potential upper and lower bound. So if we look at M equals 2. Okay, so for M equals 2, let's think about how many vertices we could potentially have. So for total vertices, we could do 2 to the 4th, and that equals 16. So that doesn't really give us a whole lot to work with. So if we have M equals 3, that means the most possibilities that that tree can have for a height of 4 is going to be 81. Well, we have the 81 leaves. We have an internal of 80. That would actually work. That gives us our minimum requirement. So this would be the least bound. Okay. So now let's talk about, if we look at our upper bound, what we want to do is we want to look at how many the leaves equal. And so we want to use our M minus 1 feature. And if we have an M minus 1 for all of our levels, our children levels, plus the one parent level. Since we have a height of 4, we have 4 children levels plus the one parent. I know that I have 81 leaves. So now I can now solve for M. So I'm going to subtract 1. So that's going to give me 80. So I'm going to divide by 4, which is going to give me 20, which means that my M, if I add 1, is going to give me 21. So 21 is going to be my upper bound for the full, because they're not going to have any that are going to be, short children anywhere. So for part B, we are asked to find M if T is balanced. So if everything is balanced where there's no holes at all, we can use our formula H equals the log M of L. Well, I know my height is 4. I'm looking for the M because I don't know what the M is for being balanced. And I know the number of leaves I have is 81. So I can rewrite this as m to the fourth equals 81 based off my log properties. And then I'm going to fourth root each of these. And so that means with the fourth root, it's going to be the answer of 3.